Assalamualaikum students, I am Nayab and today we're going to do computer. So I'm going to start with the name of Allah, the most merciful and the most compassionate. So for today we're going to read data representation, and this is the first topic of the computer IGCSE O levels book. So today we're going to read about how do we even represent the data we have in our computers or any device. So let's start. Number systems. First, we're going to read about the number systems. Number systems are the systems by which we represent our data. So there are like a lot of number systems from which we can represent data in. So first of all, it's the denary number system. The denary number system uses 10 as its base. As here written, the denary number system uses 10 as its base. It has 10 separate digits from 0 to 9. So it's the denary number system that we use in our daily lives. It has numbers from 0 to 9, and the base of that number is 10. That if we exceed 10, we take carries. So it's the daily life number system that we use in our lives, called the denary number system, and it has 10 as its base, none other than 10, and it has the numbers 0 to 9. Now there are the headings. 10 0 equals to 0, right? 10 1, 10 power 1 equals to 10, 10 power 2 equals to 100, 10 power 3 equals to 1000. We're writing 10 here because it's the base. So if we 10 power 3, that's 1000. If 10 power 4, that's 10,000. So we're using when we are using 10 as its base, we get the number as 10,000. So these are the numbers that can be behind this: 2, 5, 1, 7, and 7. Okay, so the binary number systems based on the number 2 having only zeros and ones as its values. So the next number system is the binary number system. The binary number system is based on the number 2. The denary number system was based on number 10, but this system is based on number 2. It only has two values called the zeros and ones, none other than zeros and ones. We can't use any other number in the binary number system because the base is 2, so we only use 2 digits to represent the binary language. This means that all the values are represented by ones and zeros. Some of the values are, here you go: 2 0 equals to 0, 2 1 equals to 2, 2 2 equals to 4, 2 3 equals to 8, 2 power 4 equals to 16, 2 power 5 equals to 32, 2 power 6 equals to 66, and 2 power 7 equals to 128. These are all the power of 2's. Because it's the number system is the base is 2, so we only use 2 digits to represent all the values. So if there is some value called 1 1 1 0 1 1 1 0, so here this is representing a value which is 2 plus 4 plus 8 plus 32 plus 66 plus 128. This is the represented value in here. So these are the two main number systems. One is based on the number 10, and the second, the binary number system, is based on the number 2. It only has 2 digits to represent its values. So now we're going to talk about the conversion of binary to denary. So converting from binary to denary values. So example, convert 1110110 to denary. So this number is given us in binary, and this we have to convert it to denary. Denary is the base number 10, and binary, as it uses 2 digits, it has a base of 2. So first we're going to write the headings as we wrote: 2 1 2 1, 2 2 2 3 2 4. Like this, we're going to write all the headings, and then we're going to write the number. So by writing the number, wherever we receive 1, we add them. Like here we have 1, here we have 1, here we have 1. Like we have 1 in 128, 64, 32, 84, and 4. So we're gonna add all these numbers which have 1 behind them. So 128 plus 64 plus 32 plus 8 plus 4. All of these numbers have 1 beneath them. So we're going to add them all and we get the number 236, which is the denary number for this binary value. Converting from denary to binary. So now, example, convert the number 142 to binary. This is a simple number 142 that we have to convert it into binary. So there are two methods for converting denary to binary. So the first method is subtracting the largest possible value of 2 until it reaches 0. So we have to subtract the largest possible value of 2, like the largest possible power of 2 by the number until we reach the number 0. So first we're gonna subtract 128, which is the largest value possible after 142. Then we get 14. So what is the largest possible value of 2, which is less than 14? That is 8. We're gonna subtract 8 from 14, which equals 6. 6 minus 4 equals 2, and 2 minus 2 equals 0. So here we see, so 128, we used 128, we're gonna put 1. For 128, we used 8, so we're gonna put one beneath the 8. So we didn't put 0 here, we didn't put 1s here because we didn't use them. They weren't the possible values we could choose when we were subtracting. So we're gonna put 0s behind them, but the ones we used, we're gonna put 0 beneath and 1 beneath them. So we used 8, so we will put 1 beneath them. We used 4, we will put 1 beneath it, and we also use 2, so we're gonna put 1 beneath it. So the binary number will be 1 0 0 0 1 1 1 0. Now the next method is in this method, we divide the denary number successively by 2. When we divide the number by 2, we have to write the remainder even if it is 0. So when the second method is that we have to divide the denary number by 2, even if it's odd, we're going to write the remainder. So here the diagram on the right shows the conversion from denary to binary. Once we divide it, we put together all the remainders to form a binary number. So here we are finding the binary value of the number 166. We're going to divide it by 2. So this can be fully divided by 2, so the remainder will be 0. This can also be fully divided by 2, 78, the remainder will be 0, but 39 can't be fully divided by 2. So we're going to divide it by 19 and the remainder will be 1. Okay, so here like this, we're going to write the remainders. When we divide it, so 2 9s are 18, but this is 19, so we're going to write 1 as a remainder. Just like this, we're going to write remainders if they're 0, if they're 1, and then we're going to go from up and bottom to top and form the binary number. 156 equals to 1 0 0 1 1 1 0. This is the binary value for 166 as the denary number. Then there comes another system, another number system, which is usually used in the computer languages called the hexadecimal system. The hexadecimal system, sometimes referred to hex, only hex, is closely related to binary system. It has as base of 16 and needs 16 different digits to represent each value. So this has a base of 16 instead of 2. The binary had a base of 2, and this has a number system called the hexadecimal system, has a base of 16, and it needs 16 digits to represent all values. So that would be too long. So because of this, the numbers 0 to 9 and letters A to F are used. So we can't use 16 values to represent every single value. So what we did at that, we used the numbers 0 to 9 and the letters A to F to represent the hexadecimal values. So 16 0 equals to 0. 16 1 equals to 1. 16 1 equals to 16. And 16 2 equals to 256. And 16 power 3 equals to 4096, and 16 power 4 equals to 65536. So then we're going to represent 6556 or 16 4 by 2, 16 3 by 1, but 16 2 is going to be represented by F. 16 1 is going to be represented by 3, and 16 0 0 equals to A. So this is a big table comparing the hexadecimal, binary, and denary values of all the numbers. So denary value are the simplest value, which we use in daily life, 0, 1, 2, 3 until 15. The hexadecimal values change after 9, the 0, 1, 2, 3, then 9, and then it's A, B, C, D, E, F till 15. And binary values are completely changed, and they're many complicated because it's like the compilation of 0 and 1s in every value, like 0, 0, 0, double 0, 0, 1. Just like this, there are like a lot of values just comparing to the hexadecimal and denary value. We usually use this table for converting binary to hexadecimal or hexadecimal to binary. So the conversion, again, the converting from binary to hexadecimal, this is very simple because we just have to split it and then we have to check it from the table. So there's an example called converts 10, 11, 11, 10, 0, 0, 0, 1 into hexadecimal. So this is a binary value given and they say us to convert it into hexadecimal. So first we have to split the binary number in four groups of 4 bits. So every group has to have 4 bits in them. And then using the above table, find the equivalent value. So this table here, we're going to find the equivalent value of these 3 groups, which have 4 bits. So 10, 11 equals to B, 11, 10 equals to E, and double 0, 0, 1 equals to 1. So the hex value will be BE1. This will be the hex value of this value given in the binary. Converting from a hexadecimal to binary. It is just as simple as converting from binary to hexadecimal. We have to just split them. This is the example, convert 4, 5A into the binary. So we just have to split them in the 3 parts, 4, 5, and A. And using the table, we're going to find the hex and the binary value for these hex numbers. So 4 equals to 0, 1, 0, 0, 5 equals to 0, 1, 0, 1, A equals to 10, 10. And then we just resemble them to form a binary value, which will be 0, 10, 0, 0, 10, 11, 0, 1, 10. This will be the binary value of this hex value for 5A. Now, converting from hexadecimal to binary. It was denary. Example, converts 4, 5A into denary. First, we have to multiply each hex digit with its heading value. So first, we have to, as we told, there was a table that represented the binary value, the denary value. So what we have to do is we have to take the headings of that. So this is like, we have to take the heading and multiply it. So this is the 4, 5, and A are the headings over here. Let me just do this. Yeah, here you go. So these are the headings. So 4, 5, and A, we're going to take headings. So actually, A equals to 10 over here. So over there, I also gave a note that A equals to 10. So what we have to do is multiply their headings by themselves. So 4 multiplied 256 equals to 10 to 4. 16 multiplied 5 equals to 80. And A multiplied 1 equals to 10. Actually, the A equals to 10. The A hex value equals to 10. So then what we have to do is the denary number will be the adding of all these products. So 10 to 4 plus 80 plus 10 equals to 1144. So the denary value of this hex value of 45A will be 1144. Converting from denary to hexadecimal. So example, converts 2004 into hexadecimal. We will divide 2004 successively by 16, writing the remainder until it reaches 0, just like the binary thing. But what we have to do is we have to divide it successively, writing the remainder. So 2004 divided by 16 equals to 125. And the remainder is 4. Then 125 divided by 16 equals 7. The remainder is 7. 7 divided by 16 equal remainder is 7. the hex value will be 7 and D4. So D equals 13, 7 is this, and D is 13, and this is the 4 that we gave. So the hex value will be 7, D, and 4. Now, we have to talk about the use of the hexadecimal system. First of all, the hexadecimal system language is used for the error codes. So what are actually error codes? The error codes are shown as hexadecimal values whenever an error occurs in the computer automatically generates these errors codes which refer to their memory location. So wherever or whenever an error is occurs in some processing or programming, and the computer just automatically generates codes which are in the hex form. You can also see this diagram which represents some error codes. You can also see that they're in hex form BAA, CBA. So this is in the hex form. They are usually in a hex form which are like generated by the computer whenever an error occurs. Then media access control, or in MAC addresses. It is a kind of number which uniquely identifies a device in a network. The MAC address is usually made up of 48 bits, which are shown as 6 groups of 2 hex digits. So actually, what is even MAC addresses? When like some devices or computers are interconnected, the MAC addresses are used to identify one device. Like every device in a network of devices has an identification code or number, which is called the MAC address or the media access control address. It is usually made up of 48 bits, and it is shown in it is shown as 6 groups of 2 hexes. Usually as NN, the example is NN, NN, DD, DD, and DD. Or we can also write them with the columns, double N column, column, double N column, double N column, double Z column, double Z column, double D. So where the first half is the identity number of the manufacturer, in the second half, which is the serial number of the device. So the one who made the device, the person who made the device, there is the identity number of that person, and this is the serial number of this the own device. Then there are some other uses of the hexadecimal system. Internet protocol IP addresses. Each device which is connected to the internet is given a special address known as the internet protocol or IP address. So every device which is connected to the internet, like we connect to the internet, every device, even a mobile phone or a laptop or a PC or a tablet, or whenever or wherever they are connected to the internet, they have their own IP addresses. So there are the internet protocol addresses. They tell the identification of a device, like what device is it. So every single device connected to the internet has their own IP address. It is rather in IPv4 or IPv6. So these are the two types of the internet protocol address. The IPv4 is a 32-bit address. So IPv4 is a 32-bit address in a denary or hex form. Actually, it can be in both forms, but more likely it has to be in hex form in 32 bits, where IPv6 has improved the variant of the IPv4 and has 124 bits address and hex broken into 16-bit parts in hex form. It is broken into 16-bit parts having 124 bits when formed in hex form. For example, there's an IPv6 address given here. This is AHFB colon. We always use colon in the IPv6, 7A88 colon, triple F0 colon, 3D21 colon, 2085 colon, 66FB colon, F0FA. So the IPv4 address uses the decimal point. this point, the IPv4 addresses uses this, but rather than colon as used in IPv6. In IPv6, we always use colons. So whenever you have to identify an IP address which is given, and they say that you have to identify that if it is IPv4 or IPv6. So we just have to see if there are colon or decimal points. If there are colons, that means that the address is IPv6. Then, the hex is also used for hypertext markup language. It's also called HTML. The hypertext markup language, HTML, is used when web pages are being developed because it is not a programming language, but simply a markup language. It is used in processing definitions in a presentation of text. So HTML is used in web pages on the internet, and it is also in hex. So it is not for programming, but it is used in processing definitions and to present the text that is in the web page. Now we're going to talk about the addition of the binary numbers. Example, add 00, 100, 111, and 01001010. So these two, we have to add these two numbers. So as present in the table, the binary addition will be, there will be no carry if we plus 1 plus 0. So here is 1 plus 0, there will be no carry. These are the carry values here. So there's going to be just 1, then 1 plus 1. They say that when the sum increases the value of 2, we take a carry. So 1 plus 1 equals to 0 as written here, but then there will be a carry in the next place. So then 1 plus 1, this is the 1 and this is the carry 1. So when we plus it again, they'll exceed the value of 2. So then we have to take the carry again. Then there's again a 1 here. So then the value of 2 will be exceeded again. Then there will be a carry again. But now there isn't any 1 over here. So what we're going to do, that 1 plus 0 always equals to 1. And there will be no carry. So there will be like 1. Then 1 plus 0, then it equals to 1 and no carry. 0 plus 1 also equals to 1, which doesn't have a carry. And 0 plus 0 also equals to 0, and that doesn't have a carry. Just like we add in the denary numbers, when the value exceeds the 10, and the number 10, we take a carry. But in the binary, when the value exceeds the number 2, we take a carry. Instead of taking the carry in 10, we take it in 2. Just like in the hex, we also have to do it like that. When the value exceeds the number 16, we have to take a carry. So guys, this was part 1 of this chapter. Inshallah, I'm gonna upload the part 2 of this chapter ahead. So if you like my chapter or it was helpful for you, then please subscribe to my channel and like this video. And thank you for watching. Allah Hafiz.